Alright, some more experiment video, and so I just will, since it's sort of an update video too, there are a couple of videos on the website where I respond to the comments and the statements made and all of that crap, and attempt to explain the theory, attempt to explain why I'm defending what I consider to be just logic that says that you have to conserve momentum, that momentum is essentially weight, that it is essentially force, that these things are equal, and you can't make free momentum. Free momentum is free energy. Now, if somebody wants to say free momentum isn't free energy, then explain how it's not. Explain how, 30 watts of heat going that way undoes 30 watts of heat going that way. Just explain how you can undo that. But anyway, they won't do that, so it won't matter. So anyway, so off to the video and such. It should be here, I believe. Well, at least that worked. Good. So it's already in progress, so we'll just go maybe one more frame to go to the ½ inch mark. Yeah, that works. Okay, and we'll go 1 inch. So usual routine. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's about 1/10 of an inch per frame. So that's kind of convenient. And then we'll let it crash. So it's a little metal spring. You can see it's hitting the spring now at the 2-inch mark. Alright, now there's you can see a little bit of motion, so it moves a little bit more than with a regular non-spring collision because it's not hitting exactly even. So that's not perfect, but I don't think it's enough to make that big a difference, but we'll see. See, it bounces off pretty good. So it's pretty good transfer. So we'll go to the half just to have a nice clean line. So you see a little bit of wobble up and down. So I'm trying to get rid of that. And there is some side to side, which is a real problem. So most of these, I think, came out without too much. So anyway, so let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's only 9, so 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So half. And we do see that there has been some progress on the other side, but it's even half of that velocity. So it's a pretty small velocity, half mass with half the velocity. So you're talking like a quarter or less. But it all has to be accounted for. But I would argue that the little bit that's left over here, the apparent little bit of free energy, is just a little bit, and so it really doesn't count. It's certainly far short of the 2/3 the velocity forward, and again, some of the wobble is probably creating that deception. Some of the not exactly straight. All right, so we'll go find another one and do it again. And it's such. So it's the first, like I said, I'll try some different springs, but frankly, this experiment really needs to be done on an air track. Again, this isn't bad. It shows you something, but it's not as good. There could be a better way to do these measurements. Well, I suppose I could show you the oscillation, because this one did oscillate fairly well without getting misaligned. So we'll play some oscillating. So it pretty much, comes to a, see there it missed. So after 2 oscillations it missed. Sometimes it goes 5 or 6, 7 times. That time it was just the alignment gets a little bit off because there's a little bit of movement that's not perfect. Alright, I think this one oscillates better. So we'll play this little clip. Well, let's just do it real quick with the frame rate. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's a little bit different than the other one. So we have 11 going in. I think I measured that correctly. So yeah, let's play along. So we'll go to the crash, and we'll go to the half. So we got some wobbles, but okay. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So pretty much the same outcome. So we'll just play it from here, and it should oscillate. So there's a little bounce. You can see the big one does vibrate a bit. I think the tape measure is me, so let's not count that. So anyway, we'll find another clip. Alright, this is a short distance, so this might be interesting. So let's see how this one does. I haven't released it yet. We're waiting and waiting and waiting. Alright, there it goes. So we'll go to, it's a little dangerous, so maybe we'll go to 1 1/4. So we'll go all the way to 1 1/4 and then do 1 inch from there. But that should get us our maximum velocity. So that's about on the quarter mark. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Looks like a 12. Pretty good. Alright, so let's see what the results are. 12 in. Alright, a little bit of bounce, but not much movement. That looks, whoops, that's not good. That up and down thing. No, not good. Anyway, let's count. So we have 12, so we're going to need 24. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 26, 27, 28. So it's getting marginal because you can see it's really slowing down. It has risen a tiny bit, but it was wobbling a little. So not perfect, but we'll see if they bounce. Yeah, see, it was almost to its maximum. So the velocity had already slowed down a bit. But you can see it was pretty much, okay, half. Yeah, it went less than half, but that's probably just because of the amount of velocity that was taken away. So it bounces back and forth once, and then it misses. Okay. So it wasn't a good bouncer. Alright, so we'll go find a better clip. Alright, this one seems to oscillate quite a bit, so we'll do a shorter amount of distance. So we'll just see how much it averages per frame and see what we get, and then we'll use that number. So it's like a half, a tenth, so it'd be a 20th, whatever. A little more than that. Yeah. So it's about a tenth of an inch. Let's see if we get a tenth. Yeah, we're getting about a tenth. Yeah, about a tenth. A little less than a tenth. Alright, so it's a little less than a tenth of an inch. So that would be 10 per frame, theoretically. 10 per inch. Alright, and pretty much the same going away. So let's do it from here. And just see one. It should be like half of a tenth. Obviously, pretty close to half. Half, 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 half. You know, it's a little less than a half. So it's pretty much perfect. So I'll just play the rest. So this one oscillates. It should anyway. So it goes back and forth. So it does bounce back. It doesn't bounce back much, but it bounces back with a much lesser velocity. And so that one worked pretty good. So I don't know. Let's see if I'll see if there's some better. I changed the camera angle a little, I think, and it fiddled a little, but it's pretty much consistent with what I expected. Alright, let's see what we got here. So this is pulled back a little further. We'll see what we get. Let's get up a little closer, maybe go to the 2. So that's the front edge is at the 2, not the back edge. So, for what it's worth. 1, 2, 3, 4, 5, 6, 7, Definitely an 8. At least 8. Pretty much 8. Pretty close to 8. Okay. And let's see how the hit goes. Oh, there's a bit of a bounce down, which isn't great, but we'll see if we survive it. So it's got a little bit of wobble in it. Alright, so we'll start right there. Call that a quarter. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14, but it's wobbling, you know, it's in the up phase. If I bring it down, 15. So, you know, that one you'll have to say what it's worth just because the wobble is a problem. So that one's a bit flawed. Let's see if it oscillates. I don't remember. Experiment sort of got discontinued because a bunch of snow fell on one of my awnings and I had to go out and put the awning back up. So you can see it's a lot of jitter in there. So that's, you know, a little too much jitter. And then I don't know what I did, but alright, yeah, that's probably where I had to get up to because big crashing sound. Anyway, so we'll do some more experiments, but so far nothing to indicate free momentum is possible. So till the next edition, let's see what other experiments I can do and such, so forth and whatnot. Well, maybe I'll pause and see if there's anything else to... Yeah, there's probably nothing else I can show here, so we'll just leave it at that, I think. Alright, just figure I'll throw it in. So I haven't weighed the objects, right? So it's a steel rod, and I just cut it by size. And the truth is I cut the end that was hammered. So one end is a little the small one actually has a smashed end. And I figured, you know, that would be to your advantage. I mean, the opposing people, because that would mean the small one is a little heavier than half the weight. So if there's any chance of them being off in weight, the odds are the small one's heavier than it should be, which is to your people's advantage. So I'm just letting you know that, you know, if there's a cheat, it's to your advantage, not to my advantage. So the lengths are 10.5 centimeters for the small one and 21 centimeters for the big one. So obviously that's half. But like I said, the small one does have a expanded end, you know, where it's a little bit more metal. Now I could file it off. That's what I figured on doing. But you know, until I make a decent scale, there's really no point. And such. Or buy a scale. Maybe someday I'll do that. But it's not going to be today. Anyway, till the next time and such. So forth and whatnot. This has been a draftphysics.com video presentation. And such. So forth and whatnot.